Hi everyone, how are you guys doing? I hope everyone is doing great, staying safe, trying to mingle with this current outbreak. And as you already know, from now on, we are totally switching to online course and an online course, and our lectures will be online. That's why I'm making all these videos. As you already remember, normally I would like to change my teaching style time to time. I like this actually, switching teaching styles. And this will be another switch, and I hope we will like it, you will like it. I will do my best to make it more engaging, to make it more exciting. I really normally like to work with you guys in the classroom setting, because as you know, I like writing questions on the board and walking in the classroom and checking your answers, giving some instant feedbacks. Maybe we will not be able to do that, but that's fine. I will try to make it as engaging as possible. That's why I'm going to also share my videos while lecturing at the same time. And if you have any questions about any part, you can always email me, and or we can find a way to discuss your questions. Okay. All right. As you remember, last time we finished section 7.2 and 7.1 and 7.2. It was about using power series to find solutions for differential equations. Now we are going to start chapter 3. And chapter 3 is about systems of differential equations. And if you have taken linear algebra before, systems of equations means there are different equations. Let's say if there is 3 equations in your system, which means basically literally there are 3 equations that you need to solve together. The same idea applies here. When I say systems of ODEs, ordinary differential equations, I mean there will not be only one ODE, but there will be a couple ODEs, maybe 3, 5, whatever, okay? So we are going to try to solve these ODEs in this chapter. Okay, so let me share my, I think, yeah, this one. Yes. Share. Okay. So, I hope I can move my, okay, anyway. So, we're gonna start with section 3.1, Intro to Systems of ODEs. And these are directed notes. When I say directed notes, I mean there are some parts I'm gonna fill without you, and I'm gonna post these notes all on D2L. So what I suggest you guys is you can download those notes on your own, or you can maybe use some tablet or online tools to fill. You can watch the video and fill at the same time on your own by yourself. Okay. I hope it will be engaging for you. All right. So why are we doing that? First of all, why are we dealing with not only one ODEs but more than one ODEs at the same time? Because when we look at some physical processes, there are actually more than one systems. There are more than one differential equations going at the same time. That's why in many applications we can say that, as it is written here, there is actually not only one differential equation, but there is a systems of differential equation. There is a system of differential equation, which means there can be n equations. Oh, okay, I have to draw, and let me pick my color as blue, my favorite color. Okay, there are now n equations of n unknowns. Okay, so let's assume that there are 5 differential equations with 5 unknowns. Okay, but those unknowns are all depend on the same independent variable. All right. For example, let's look at this example. Let's say we have 2 independent variables, y1 and y2. So these are 2 functions. They are both depending on x. Okay. So we could write a general second order system this way. Okay. So y1 double prime, since this is second order, right? It should be double prime, is equal to a function with respect to y1 prime, y2 prime, y1, y2, and x. And similarly, y2 prime is another function with respect to these y1 prime, y2 prime, y1, y2, and x, okay? So now we have two equations to be solved, right? We need to solve two equations with the same unknowns, same independent variable. Okay, so this is a rough introduction about